Do you have an RV absorption refrigerator that performs well in the cooler weather of the fall and winter? And yet in the summer, the heat of the summer, it tends to underperform and struggle to maintain safe food temperatures? If so, then this video is for you. We're going to discuss how an absorption refrigerator works and why heat and humidity affect its performance. We're then going to discuss a solution, and then we'll take measurements, real-world data measurements, before and after the solution is implemented so you can see the actual effect and improvement in performance of an absorption refrigerator that can be achieved. Stay tuned, more to come. Hello, and welcome to this edition of the Watson Chronicles. My name is Ron, and this edition is being brought to you by Sherlock RV Inspections and BeechLane Products out of Sanford, North Carolina. The purpose of this video is to talk about absorption refrigerators and the way they perform in an RV. We're standing in a Winnebago 2018 27K, a Cambria model, and it has a 6 cubic foot RV refrigerator. The owner of this RV has complained that the RV refrigerator did not perform well on their last trip out at the coast, and we've checked that out. And so there are several factors that occur that it can cause that to happen, and we're going to deal with those in this video and then talk about improvement factors. When we were studying the improvement ways to fix this, we ran across BeechLane Products. They offer this dual fan assembly that would mount to the exterior vent. We reached out to them and they graciously provided us a fan to use in this test installation and video, and to provide a test of their product. This is not a paid video. We're not being sponsored by BeechLane Products, and what we're going to give you is a very objective and thorough performance review with real-world measurements before and after as to how this fan has increased the performance efficiency of this refrigerator. So with that, let's get started. RV absorption refrigerators transfer heat from inside the refrigerator box and the freezer box to coils in the back. The exterior of the RV is vented. Those coils are designed, and that whole vent is designed as a chimney effect, so that airflow, convection airflow, moves in from the bottom vent up across the coils, pulling the heat away from those coils and sending it out either through the roof or the upper vent if your refrigerator is in a slide out. If the ambient temperature is hot, like it is here in Florida, then the efficiency of the heat transfer, the extraction from those coils, is not as good. The BeechLane Twin Fan that mounts into the back of that cavity helps to improve the airflow and therefore the extraction of heat, which should then improve the overall performance of the refrigerator. That's what we'll be determining through this test and installation.
This is a diagram of the back of the absorption refrigerator. The ammonia, hydrogen, and water solution contains sodium hydroxide as a rust inhibitor in this closed system of coils. The refrigerant solution is boiled using either propane or electric heat in the boiler at the bottom right of the diagram. The vapor rises to the top, and as it condenses, it absorbs the heat present in the freezer and refrigerator compartments. The liquefied solution returns to the bottom where the cycle begins again, making the temperature in the refrigerator and freezer colder with each cycle. The heat removed from the freezer and refrigerator must be eliminated for efficient performance. The cavity at the back of the refrigerator compartment acts as a chimney, drawing air in through the bottom vent and evacuating it out through an upper vent or a rooftop vent, depending upon your RV design. To help with this heat transfer away from the coils, the BeechLane fan employs two high-performance 12-volt fans. When mounted in the upper sidewall, vent the fans blow the heat out, creating a draft pulling cooler air in through the bottom vent.
There are three factors that tend to affect the performance of an RV absorption refrigerator. They have to be level. They have to have good airflow across the coils, and that the seals on the doors need to be good and tight to keep the airflow from the ambient and humidity inside the RV from getting into the refrigerator and freezer compartments. Let's look at each of these conditions individually. Level condition. RV absorption refrigerators do not use a compressor. They rely on gravity and thermodynamic principles in order to circulate the refrigerant. So you need to be within 3 degrees of level for it to operate properly. If your RV does not have a hydraulic or electric automatic leveling system, then you need to level the RV manually yourself by putting blocking underneath the low side wheels. BeechLane has a product called a camper leveler product, which can get you up to 4 inches of height gain from a 1/2 inch to 4 inch, and you may want to check that out if you do need that. I have a set. I can vouch for their quality and durability, and I use them quite often.
Looking at our refrigerator coils diagram again, we see that gravity plays an important role in returning the condensed liquid to the absorber vessel at the bottom. If the refrigerator is operated off-level, over time the sodium hydroxide rust inhibitor will clog the coils and eventually prevent the refrigerator from operating. This is why keeping the RV level is essential to maintain an absorption refrigerator performance and longevity.
Let's talk about the door seals. Over time, as the refrigerator ages, the seals tend to lose their elasticity, and they don't seal as tightly against the refrigerator body itself. That allows the air to get into those compartments and reduces the efficiency of the performance of the refrigerator. You can tell what's happening, if that's happening to you, just by the frost that might be building up in the freezer and or the refrigerator. And you can actually use a dollar bill test, which is place a dollar bill and close the door up against it. That dollar bill should have some resistance in removing it against that door seal. That door seal should apply a little bit of resistance there, and it should not come out freely. And so if you find that you're getting a lot of airflow infiltration into the refrigerator cavity, then you should have the RV taken a look at by a certified RV technician, and you can locate one near you at rvtaa.org.
To test your door seals, close the freezer and refrigerator doors while holding a dollar bill in the cavity. There should be some resistance felt when pulling on the dollar bill, indicating a proper contact between the door seal and refrigerator frame. As mentioned earlier, airflow across the coils is one of the 3 areas that affects RV absorption refrigerator performance. Before attempting to add performance enhancement devices to the refrigerator, you should verify that the vents and chimney flue are not clogged and properly configured. Our test RV has a lower vent panel with 2 vents. Both vents have insect screens installed to prevent mud daubers and other wasps from building nests inside the flue and creating an obstruction. After determining that the inside bottom vent compartment was free of obstructions, we proceeded to examine the upper vent area, which is on the roof of our test RV. The upper vent screen was clear and unobstructed with the exception of one small wasp nest at the left corner, which was removed. At this point, we have determined that the airflow is unobstructed, that the RV is level and the coils are not clogged, and that the door seals are good. The only factor remaining that would adversely affect the refrigerator's ability to cool properly is the high heat and humidity of the environment. We can now proceed to implement improvements to the airflow across the coils in order to improve the absorption refrigerator performance under these conditions. The BeechLane Twin Fan assembly arrives with all the tools and accessories you need to perform the majority of installation configurations. The instruction manual is clear, concise, and easy to follow. Let's begin to review the installation process for our test RV.
The fan comes already preset to blow air in a certain direction. These brackets are mounted for the airflow to blow in that direction. If you have a refrigerator install in a slide out and you're installing this fan as recommended in the upper vent assembly, then you would want to leave it just like it is. That way the upper vent would create a draft pulling air from below through the bottom vent and across the coils and venting it out. In our installation in this Class C, the refrigerator has a vent. It's in the side. It's in the sidewall, so it has a bottom vent and an upper roof vent. So this fan, being in the bottom, would actually try to create airflow in a reverse direction. So we're going to have to change the direction of airflow of this fan as it is mounted against the grill assembly, which would mean reversing these guys and just flipping them around to this side using the Allen screw. And you've provided an extra heavy Allen screw for this particular one, so you do that. So you do have the small screw that's designed for this, small Allen for these guys. The big one, if you have to change the direction of this airflow, comes with a thermostat and controller. Comes with the Y connector that will connect these wires together and over to the controller. Comes with two 3M adhesive pads that would be used to mount the fan speed controller. I personally, these are kind of thin. I'm going to use a heavy duty one, 3M adhesive pad that is designed for extreme temperature considerations, that kind of thing. This comes also with wire nuts. Now, as an inspector, when I inspect an RV and I see wire nuts, I flag it as a safety issue. The vibration, road vibration in an RV is enough that these things do work loose and give you a bad connection. So I recommend replacing those with WAGO connectors. So take them out of there, and I'll be using the triple, and these are a clip connector. So when I tap into the 12-volt wire in the RV refrigerator compartment, I'll run the main 12-volt in there and clamp it down. I'll then run the positive for this guy in the center, and then also, or the negative, one of the wires, and then the last wire that'll go back to the refrigerator as originally configured in that one. And we'll do that for the positive and the negative wires, and then that's a very positive connection. Withstands the vibration of the road. These are available on Amazon. I'll put a link in the description below to a package of these. I would use these always instead of wire nuts in the RV. So I'm going to be replacing that with that. I'll be replacing those with a heavier duty one. Other than that, the next step is going to be to reverse the fan airflow. Okay, here you see the brackets have been removed. There's the screws for that. I just slid them off to the side, and this bracket as well. So now to reverse the flow, we just flip the fan over, leave the brackets where they were. So you see the difference now that you've got the fans with the wires here it's showing. And then we're going to slide these brackets back on. Line up the holes on the sides. Then it's just a matter of attaching the screws, and then when this thing is mounted, the fan direction should be in the proper where it's going to blow air into that bottom cavity, up through the chimney effect, across the coils, and then out through the roof vent. All right, here you see the brackets have been reversed. The fan has been flipped over, so now you see the wires are exposed on the inside direction this way. This side here will mount to the vent. So when we turn it on, you go to manual, and now the fan is blowing in this direction toward me. It'll be pulling air from outside through into the cavity. It'll be directed up the chimney effect, across the coils, and out through the roof vent, and that should improve the refrigerator performance. The brackets and the screws are powder coated, and the powder coat has gummed up the screws threads, so it'll be more difficult to actually fasten when you're trying to attach it to the vent. So I recommend just cleaning the threads out first, using the small Allen screw, get it started, and then just work it back and forth until you've seated the screw all the way. And that'll clean the powder coat out of the threads of the screw and the bracket, and it'll make it a lot easier to do the install when you're done. So just do that, repeat that for all of those screws, and get that done before you empty your install. Alright, here we see the fan. It's been reversed for airflow. The brackets, the reverse brackets have been attached. Now we've attached the clips. There's a clip that goes into the slide here and a clip that goes into the fixed hole here. And that's going to give you the adjustment range that you need. The little hooks go to the outside and do the same on both sides. Don't tighten them all the way. Just leave them snug just so you can adjust. These will adjust in and out. These will adjust the same way as we then try to fit it onto the vent. Alright, after multiple attempts of making this fan fit this particular RV's configuration, I think we've hit the 1% of the RVs where the fan does not go directly. These mounting clips, once they're in place, they lift the fan and position it up higher like that. So it's up higher in there like this. And the way this goes into the RV, that fan cannot be any taller than these mounting reinforcing pins here. So removed all of the clips from it, and I've decided to just zip tie the fan to the vent screen. Make sure you run the zip ties crisscross underneath the reinforcing bracket so you don't put too much strain or any strain on this middle centerpiece. So we will zip tie this together. As you can see, I've rubbed them through all four corners. We'll zip tie it to the assembly, test fit, dry test fit it again into the RV, and then we'll take the next step from there. Okay, so the fan dry fit worked perfectly. This is how it is mounted. We retained the outside brackets that we used when we reversed the fan direction flow. Eliminated the clips that connect up here and replaced them with zip ties that would then be used to hold that in place. Holds it very securely, did a dry fit, and everything worked fine on that. The direction of the fan should still be correct. The fan is now blowing in, so we'll suck air in, up through the chimney effect, extracting heat off the coils and out through the roof vent. The other measurement that you need to be concerned about is going to be how deep this fan is and where it's positioned. You notice I have it positioned slightly offset. I have an electrical box over on this side in my configuration. There is a propane line that comes up this way, but it clears it properly. Installed like this fan takes up 12 3/4 inches in length, is 5 3/4 inches tall, and it adds 1.5 inches of depth. So you got to make sure you have enough clearance from all of your propane lines, electrical lines, and everything else in your cabinet to make sure this will all work. So this is the configuration. Our next step now is to go and actually install it in the RV, and then following that will be the real-world test to see how its performance enhances the existing standard performance of the refrigerator. Alright, before we do our installation, just review some of the tools that you may use. These are some that I expect to use. Use zip ties in order to do some cable management. A screwdriver, possibly a Phillips, and maybe a straight slot depending on where you're going to make your 12-volt connections. Use a utility knife to cut away insulation as well as needle nose. Wire cutters. We've already talked about the WAGO connectors. We'll be using those to make all of our electrical connections. And some wire strippers. And of course the multimeter. We want to verify that the power is off when we make our connections, and we also want to verify the polarity of where we are going to connect. The fans do need to have the plus to the plus and the minus to the minus and the 12 volts. And not all RV color code conventions are the same, or nor are they labeled. So we're going to verify that with a meter, and then there will be no question as to where we're making our connections. Okay, here we are at the refrigerator compartment on the outside of the RV. These are the wires that are providing 12 volts. In this case, they go up to here and plug into the control module for the refrigerator. I don't have screw connections there, so I figured I would cut the wires and just tap into them down here with the WAGO connector. You never want to cut any power wires in an RV with power connected. So the first thing I did was I turned off the air conditioner so there would be no load to the RV, and then I hit the battery disconnect switch. Don't trust that. That does not always disconnect all 12 volts. I came back and I measured again, and I still had 13.2 volts here. That tells me that even though the battery disconnect switch was engaged, the converter, because I'm still plugged into shore power, is still providing power to the refrigerator control board. So I had to disconnect the shore power, and now I have 0 volts here, and I can safely work with wires and not going to be concerned. I mean, you can't get shocked on this 12 volt, but you can do some welding if you cut across that and ground. So you always want to have all your power disengaged before you work on the electricity in an RV. All right, with that doing, our next step is to actually cut into these wires and make the connections to the BeechLane fan.
Before we cut wires, we need to determine which color wire is the positive 12 volt. Using our multimeter, we determine that the yellow wire is the positive wire. Now that we know our color code, we disconnected our house batteries using the battery disconnect switch. We retested with the multimeter to make sure power was off, and, as mentioned earlier, determined that the power was still present. Our next step was to disconnect from shore power to effectively turn off the converter charger. Measuring again with the multimeter confirmed that power was indeed off. In some RVs, you may have to physically remove the positive wire from the house batteries directly. We can now proceed to cut the wires and splice in the BeechLane fan assembly.
All right, installation is nearly complete. We have tapped into the wires. We saw that the yellow on our configuration was positive, so I've connected it to the red coming from the BeechLane fan. So the main power comes in, goes to the fan, and goes to the refrigerator. And then the negative side goes to the yellow on the BeechLane fan. And so then we've got it coming in and then going back out, coming off of there. Okay, we mounted the fan controller onto the metal flat here as opposed to this plastic piece, which was a little bit too loose. Cable management. The thermistor is located up here on the hydrogen line return. And I left enough connector cables so that when I remove the cover in order to service back here, I have enough slack where I could just disconnect it and then set the housing down on the floor. So now we will then commence to our testing and see how the performance improves with this fan. Okay, the BeechLane fan has been installed. The seals of the refrigerator door have been checked to make sure that they're not the problem. We know the refrigerator has been working as intended. There's no leaks in the coils and the refrigerant and everything else. We've leveled the RV, so we're leveled front to back and side to side, which is the way an absorption refrigerator needs to be, within 3 degrees of level. And then we've inspected the roof vent, that the chimney effect in the back of this refrigerator needs to be clear. We've inspected that, cleaned out just a little bit of debris. There was not really much there, but you always want to make sure that that is not clogged and that works. So everything else is okay with respect to that. So the only thing that the variable is going to be now is whether the fan can improve the performance of this refrigerator. In the freezer, I have a wireless sensor thermometer that is broadcasting to the thermometer to give us a reading, and I have a wireless sensor in the refrigerator located in the middle. We're going to run the refrigerator on electrical power, shore power, and we're going to set the temperature to maximum, which on this Norcold is set at 9. On your refrigerator, you may have a thermistor on the coils inside that you have to adjust up, depending if you want things colder. So the refrigerator now is going to start to stabilize. We're going to let it run overnight, and then we'll check it again tomorrow morning at 6 in the morning and take readings. We're going to take a reading of the outdoor ambient temperature, the indoor temperature. We're going to keep the indoor AC running at 85 auto cool. So we'll have the difference between outside, inside, freezer, refrigerator at the beginning of the day. After that, we're going to put a thermal mass in the freezer and a thermal mass in the fridge. That thermal mass will take the shape of a bowl of water. It's about that big. I'm going to put one in each. The only time the doors will be open is to set those in and close the doors again. And then that will simulate having same type of food and packing in the refrigerator. We will take 3 more readings through the day, every 3 hours. So if at 9 a.m., at noon, and at 3 p.m., we'll record all the same temperatures. Given that, we'll remove the thermal mass. We're going to leave the refrigerator set at high cool 9. We're going to let it run overnight with the BeechLane fan on this time. So the BeechLane fan is set in the back there. It's set to run at 80 degrees internal temperature in the cavity back there. The next morning, 6 a.m., we repeat the process. Only this time we're going to get readings to see the effect of the BeechLane fan. Again, we'll take a reading at 6 in the morning, insert thermal mass, the same amount, same place, and then measure again at 9, noon, and 3. That would conclude the experiment, and we're going to take a look at the delta T, the change in temperature, change in performance of this refrigerator with all things being equal. And the difference will be the effect that the BeechLane fan can provide for you.
The test was conducted over 2 days under severe conditions. The thermal mass was water obtained from the RV fresh tank, which was at 80 degrees Fahrenheit. 1 bowl was placed in the freezer and 2 placed in the refrigerator compartment. This is an extreme test of an absorption refrigerator performance, since we would never put food products in either of these compartments at this temperature. However, it provided us a standard baseline starting point. The baseline performance test on the first day had the more favorable weather conditions being a cloudy day and a high temperature of 90. The refrigerator took 9 hours to recover from the thermal mass and achieve food-safe temperatures conditions. On day 2, we experienced the heat dome conditions over Florida with the outside ambient temperature exceeding the thermometer capability to record it. I listed it at 120 degrees plus. Even under the more severe weather condition of the 2-day test, the added ventilation provided by the BeechLane fan improved the refrigerator food-safe recovery time by 33%. Impressive. We decided to continue the test of the BeechLane fan performance improvement with more realistic refrigerator use parameters. We packed the refrigerator with pre-chilled food and frozen items. We were careful to not overstuff the refrigerator, allowing for air circulation in the compartment and left room for frozen ice packs to aid in the recovery process, which is a good practice to follow with any absorption refrigerator. The refrigerator was run overnight on the highest cool setting. The ambient temperature was 78 degrees Fahrenheit when we packed the refrigerator at 9:37 in the morning. When the doors were closed, the freezer was at 30 degrees and the fridge was at 53 degrees. Within 57 minutes, the refrigerator had achieved food-safe conditions of 10.9 degrees in the freezer and 38.3 degrees in the refrigerator. The BeechLane fan performs as intended, and we highly recommend it. I hope that you found this video informative and that it helps you improve the performance of your absorption refrigerator that may struggle in warmer and high humidity environments. If you are considering an RV purchase in the southeastern United States, please contact us. We are mobile NRVIA certified inspectors and offer inspection and agent on-site consulting services in this area. Thank you for watching, and we wish you safe travels.